Hi, this lesson is on vectors. Any quantity that we deal with in physics is either going to be classified as a vector quantity or a scalar quantity. And the difference is really just the direction. Scalars do not have direction, while vectors include direction. So for example, if I'm asked to find the speed of my car as I drive down the road, it might be something like 50 kilometers per hour. But the velocity of my car has to include a direction. So the velocity might be something like 50 kilometers per hour east. Other quantities that are vectors like position, displacement, and force also need to include a direction, while scalar quantities like distance, time, and temperature don't have direction. Now, we can graphically represent a vector quantity with an arrow. And an arrow has a pointy end, which we're going to call the head, and the non-pointy end, which is the tail. And the relative length of our arrow is the magnitude of our vector. And magnitude is really just a fancy word for size. And if we take our vector and we put it on a coordinate system so that the tail of the vector is at the origin, and let's make this basically an x and y coordinate system to start with. So that's our x-axis and our y-axis. So the tail of the vector is at the origin. This is the magnitude or the size of the vector. And the angle that this vector makes with the x-axis, which we call theta, is the direction of this vector. So this angle here is an angle, let's say 35 degrees. And in terms of giving a direction, we can't just say 35 degrees. We have to give a direction. So this is 35 degrees above the positive x-axis. And again, it's important to distinguish between the positive and the negative x-axis because there is also a vector on this side that is also 35 degrees. But obviously, these two vectors are pointing in very different directions. This is an angle 35 degrees above the negative x-axis. Now, we can also give the direction of this vector using this angle in here, which I'm going to label phi. So this angle obviously is 90 minus 35, so I would write phi is an angle of 55 degrees. And it's to the right of the positive y-axis. So both of these angles and directions represent the direction of this vector. Both are correct. Either one written down on a homework question or an exam question would be marked as correct because they both give the same direction. Now, if we were to change our coordinate system so that this is a compass direction, so this is north, this is east, and this is south, this angle now, still being 35 degrees, is an angle relative to north, east, south, and west. So in this case, it's an angle which is north of east. So I'm starting at east, which is this line here, and I'm going 35 degrees towards north until I reach this vector. So the direction here is 35 degrees north of east. Again, we can write the equivalent angle over here as being 55 degrees. And this is east of north. So again, both of those directions give us the same direction for this vector. Both are equivalent, both give us the same answer. Both would be marked correct. Okay, I hope that these examples and the ones in the textbook give you a good idea of what a vector is and how to represent the direction of that vector. In the next video lesson, we'll talk about how to add and subtract vectors. If you have any questions, make sure you come and find me in class one day and I'll be happy to help you.